Ladies and gentlemen, thank you so much for your attention. And it's a great honor for me to welcome you. My name is Richard Damania, and I have the singular honor and privilege of hosting and being the chair for this session, and I'm the chief economist of sustainable development. Welcome all to this session, which is on climate change and sustainable cities. And indeed, this is a topic that is really at the core of a lot of things that the World Bank is actually doing at the moment. In fact, at the last Conference of Parties in Egypt, the World Bank released a big flagship report on precisely this topic on climate change and cities, who pollutes most, where are the vulnerabilities, and so on. So this is really incredibly relevant in terms of what we are doing. And indeed, the whole topic of climate change has pervaded a lot of the analytical work and a lot of the lending and the advisory work of the World Bank. What we tend to do is to use big models, as we normally do, like MFMOD and CGEs, and simulate what the impacts of climate change are going to be. But I think the talk that we're going to hear today is especially relevant because what it does is it brings data and reality in terms of what is happening to really tell us what we should actually expect. So rather than relying on assumptions of the modeler and model assumptions, we actually get data. And to take us through that, who better than Michael Greenstone? And to many of you, he needs absolutely no introduction whatsoever. Michael, as many of you know, is a Milton Friedman Professor of Economics at the University of Chicago. He's a director of Energy Policy Institute. He's a member of the Academy of Arts and Scientists. He is the editor of the Journal of Public Economics. He's a senior fellow of Brookings, and the list goes on and on and on, but I won't eat into Michael's time. And in terms of Michael's publications, indeed, they're seminal in so very many ways. Everyone, I guess, over here has read his work on air pollution in China, India, and elsewhere. He's now working on trade in PM 2.5, that's pollution markets. His work on water quality, published in the AER, was also seminal. We're going to hear from Michael on the social cost of carbon, and work that I'm sure all of you are excited, you've heard about, and so are excited to learn what he's actually discovered. Without further ado, the floor is yours, Michael, and thank you so much for being with us.
Thanks very much for that very kind introduction. And I'm going to talk about some new work that I've been doing with several colleagues on trying to rebuild our understanding of what the damages from climate change will be. And a key find, so, you know, there's the old joke about a good talk is one where you tell the people what you're going to tell them, you tell it, and then you tell them what you told them, just so it could possibly sink in. And so let me start with what I'm going to try and say. So I'm going to talk a lot about how there's been advances in economics and climate science that I think really have allowed for a big step forward in the quantification of estimated damages from climate change, both globally, and then I'm going to emphasize locally, and we'll talk about what that means in practice. What's emerged from that is that the damages are much larger, probably about 4 times larger than we had previously understood. And much more heterogeneous than previously thought. Their costs are especially concentrated in today's poor and hot places. And, you know, in homage to the theme of this conference, they're going to be estimated to be larger in rural areas than urban areas. I'm going to end with a focus on the social cost of carbon. You know, I love the social cost of carbon. I think of it as the most important number you've never heard of. And it is an estimate of the damages associated with the release of an additional ton of CO2. And as I said, those estimates are probably now about 4 times larger than we had understood before we were able to bring data and some new methods to bear on this. And you know, to try and put that in perspective, if we just took this year, you know, this year's estimated emissions and multiply them by the social cost of carbon, and since CO2 stays in the atmosphere forever, I actually think that's appropriate, since even the planet's whole emissions in 1 year are probably marginal to the stock that's in the atmosphere. we're probably, we did about $7 trillion worth of damages, and this is probably an underestimate, which is about 7% of global GDP. Okay, so a theme, a thread that I'm going to try and pull through this, it's really, I want to come across, is that climate change is this global challenge. It's emissions from Memphis do the same as emissions from Mumbai, but its impacts are felt locally. Here's a picture from the floods this summer in Pakistan. And then I'm going to, the next picture I'm going to pair with this, it's obnoxious and uncomfortable, and I'm putting that up there on purpose. And I want to highlight the disparities in how the world is going to adapt and what the impacts of climate change are going to be. On the one hand, you have this awful situation. This person's life has been turned upside down in Pakistan. And then on the other hand, there's big swatches of the world. And this is, I'm going to come back to this in a quantitative way at the end. Big swatches of the world for which climate change is going to mean more air conditioning, to a first approximation. And it should make you feel, or I don't know if it should make you feel uncomfortable, it makes me feel uncomfortable, but it's something, these visual things are a good way to get ideas across. So let's just start probably where the literature began, which is there's something called integrated assessment models. Probably in this room, many people know what it is. We can thank Bill Nordhaus for them. He was really an incredible pioneer that in many respects, everyone is standing on his shoulders. And who works on climate. And so these are just what, from his model and a couple other similar models, we probably knew on the relationship on the horizontal axis between changes in global mean temperature and changes in GDP. This was all, and I'm going to make this point a couple times, this is all before we actually had data and computers. And so these were based on very common sense assumptions. It's also true that that approach didn't allow for a lot of geographic resolution. His Rice model divides the whole world into 12 places. You know, if you want to be in a very US sense, it's like saying that the impacts of climate change in Miami are going to be the same as they are in Minneapolis, when instinctually you understand that's not true. And it's this heterogeneity that I think is really important to understand and that we're beginning to unlock. And to just make the point, you know, belabor the point about that we have been for too long relying on a world without computers and data. The three graphs to your left are a histogram of the dates of publication of the papers that the integrated assessment models were based on. And you can see most, these were made in the 90s, and so most of the papers were in the 90s. And then the graph to your right is demonstrating there's been an explosion of research in trying to understand empirical research on the impacts of climate change. And so those IAMs are kind of out of date on that. And Maureen Cropper's on this panel, chaired a National Academies panel, and we put a nice quote up from there that they're summarizing this. Okay, so I'm going to give you now a flavor of what some of the work that I've been doing with some of my colleagues, co-authors and friends, on trying to rebuild or build afresh kind of an empirically based understanding of what the impacts of climate change will be. We'll go to some, this is done sector by sector. So the first is the relationship between temperature and mortality. I'll show you something about electricity consumption and something about labor supply. I won't go into, we don't have time to go into as much detail as I would probably like on each of them. But it will give you a flavor of how we approach this. And so this is a kind of a product of the Climate Impact Lab, which I co-founded with Saul Shung, who's at Berkeley, Bob Kopp, who's at Rutgers, and Trevor Hauser. And together it's now probably a team of 30 or so trying to do this. So one really nice thing that I think comes out of this is that instead of dividing the world into 12 regions, we're able to divide it into about 25,000 regions. And so that's going to allow, or that allows for much more granular understanding, and you don't get stuck saying that the impacts in Miami are going to be the same as they are in Minneapolis. When we set out to do this, we gave ourselves the following principles that we would try to adhere to. as much as possible. They should be based on the best, some of these are a little bit like, do you love your mother, or the good housekeeping seal of approval. It's hard to be against, sometimes hard to do, but they're should be based on the best available empirical evidence, should be based on the best available climate models, should be globally representative. That sounds like a no-brainer, but I think in practice, the literature has been hamstrung by not having data from around the world. The estimate should account for adaptation, the benefits of adaptation and the cost of adaptation, and there should be an effort to value the uncertainty that we have about climate change, as well as its unequal impacts. And so we developed this horribly named model, the Data-Driven Spatial Climate Impact Model, DSIM, to try and do all of that. And so, as I said, we kind of approach this sector by sector, and then we pull it together in an integration approach. And to this point, we've done 5 sectors, but there are more sectors in production. So, and that's the sense in which, I mean, we probably have an underestimate. There are things that are out that where the light is not shining and we haven't counted yet. I'm going to go into this in some detail, but here's just like the geographic distribution of damages. Blue is good, so those places are going to benefit across the different sectors, and we'll start to dig into them. And it's important to say that whatever estimates you get are going to be very dependent on what you assume about how sensitive the planet is to concentrations of CO2 in the atmosphere, and that's encoded in the beautiful phrase RCP 8.5, and what you assume about future socioeconomic patterns. And so those are our assumptions here, but the estimates are robust can be done with any set of assumptions. Okay, so what do we do for mortality? Let's see if I can make the slide go. Oh. Okay, so what do we do for mortality? Okay, so this is drawing from a paper that we published last year in the QJE. So the first thing is, and again, this sounds a little bit like love your mother, love apple pie, things like that. Like we just tried to collect data from around the world. Like an enormous limitation of some of my previous work on the relationship between temperature and mortality is that it was only in the United States. And the United States is, about 1/25th or 1/24th of the global population. Now, getting mortality records from around the world is complicated, and many countries don't have them. In the end, we were able to get it for about 55% of the global population. Of course, if you get India and China, you're on a, you have a running start. And you can see the places we have. And now I'm just going to show you when we try to relate the kind of headline finding is, and I'll just say it in English, first is that there's a U-shaped relationship between daily temperature and annual mortality, only present in data for people over 65. For other age groups, it's not there. And then that U-shape is flattened by 2 things. If you're richer, it's flattened, so that's due to that's just due to being wealthier and doing things to protect yourself. And it can also be flattened by the climate that you're exposed to. So the impact of a very hot day in Houston is much less than it is in Seattle. You could think of that as kind of a heuristic to carry around. So just to show you what these response functions look like, you can see for less than 5 and 5 to 64, around the world, there's just not that much relationship between temperature and mortality. But for over 65, there's this very sharp U-shape. And I want you to carry this U-shape. This U-shape emerges across almost all sectors that we investigate. Here it's just for greater than 65. And then I'm going to show you, this is like, working with data is like one of the most disappointing things you can do, because the data, you have these great ideas and the data always lets you down. This is like a rare example where the data did not let us down. So we had this idea, that places that are hotter are going to be better protected against when hot days arrive, because they will undertake in all kinds of adaptations to do that. And so I'm just going to plot now the impact of a day at 35C maybe it's 30C, no, it's 35C, and that's the average, not the high. Its impact on annual mortality rates. And so I'm going to do that decile by decile of climate. So this is the coldest decile in the world. Now I'm going to go to the second coldest decile in the world, the third coldest decile of places in the world, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Okay, and so it's amazing. Like in the data, it's actually true. Places that get many more hot days, when a hot day arrives, have a much smaller, there's a much smaller impact of that hot day on mortality. And so in our estimates of what's going to unfold over the course of the century, we're going to account for places adapting to these higher temperatures. And I'm not going to have time to talk about it today, but this is the benefits of that, but we're also use a kind of a revealed preference technique to back out what the costs of those adaptations are as well. Another thing that emerges, and I want you to think about when you think of that U relationship, is that it varies a lot with income. And so here is the lowest tercile of countries in the world with respect to income, and this is their relationship between temperature and mortality rates. And what you can see is that now I go to the highest tercile, and you can see that there too is an effect of high temperatures, but it's muted, and so you can see income is protected. And so when you account for what the impact of climate change are going to be, you shouldn't just assume people are going to be as wealthy as they are today. You have to make some assumptions about how their wealth will evolve over time, and as people get richer, the impacts on mortality will decline. And so we find that in the data, and that's the difference. Someone put this up earlier today. This is the full mortality risk associated with the changes in climate that are projected under RCP 8.5, which is a rapidly warming scenario, probably more quickly than I think the data would now support. But nevertheless, it's a useful benchmark. And this is the full mortality risk around the world. The blue places are places where mortality risk will go down. Now, why is that? Those guys are getting rid of all those cold days that are so dangerous and not adding many of the very hot days. And then the red places are places where you can see them moving up that response function, so there's just large increases in mortality. And something that is outside of our estimates and has been a theme today, in fact, there was a whole panel on it, is migration. And, when I look at this, you think, wow, there's actually a pretty straightforward solution to climate change here, which is the people in the red should move to the places in the blue. And if you had a world without borders, and you had costless moving, and you thought that Russia was going to be totally open arms to a couple 100 million Pakistanis and Indians and Bangladeshis, you might think that that was going to work. But instead, I think that's probably not going to happen. And it's going to impose all kinds of pressures domestically and internationally. And so you could think of summarizing a big part of the climate problem being that the places that are getting worse are unfortunately where most of the people live. And the places getting better are places where not very many people live. And if by some accident that had been reversed, we might have very different views about climate change. Okay, I think it's also useful to look at countries that have been especially kind of in the bullseye. Pakistan is definitely one. The projected increase in mortality risk is like more than three times the current heart disease rate in Pakistan. This is the end of century. In Ghana, it's about 4 times respiratory infections. It's also fascinating how much variation there is even within these countries. Okay, and then I'm going to drag this along at various points. I think I did these calculations for this talk, and it's part of a broader paper on inequality that we're working on. But I was just kind of shocked when we put these together. So this is the mortality risk for 3 sets of countries in the world. The first is the OECD. 1.4 billion people, per capita GDP of about $42,500. Then low income, defined by the World Bank definition, where you got about 700 million people, per capita GDP of 622, and then kind of the middle. And you can see that just on the temperature-related mortality impacts of climate change, how unequal this is projected to be. Really enormous increases in low-income countries, very large increases in the kind of middle, and very small increases in the OECD. Now, why is that? Well, that's these two things I was pointing to earlier. These are pretty temperate places to begin with, who are probably going to get rid of some cold days that are killing people. And it's not going to get so hot that they'll be in the upward running part of the response function. Plus, they have these muted response functions because they're wealthy. Given the theme of this conference, I felt compelled to do this for rural and urban. And here you can see that in today's rural places, the full mortality risks are projected to be, maybe double what they will be in today's urban places. And break it out there. Okay, so if we were to pull it all together for mortality, what's interesting is if you take off the table the fact that people are going to get richer and people are going to, and the adaptations that people will do in response to it getting hotter, you would be at this orange line, really kind of an earth-shattering increase in mortality. But once you allow for adaptation, including its costs, which I haven't explained how we did that, the damages are about 63% lower than they would be without this income gain, adaptation gain. This is just, if you want to play around with this data, it's available on a UNDP website. Okay, I'm going to now, so that's mortality. And we're now going to move to electricity, just to give you, not in as much depth, but to give you some sense of what this exercise is producing. In the case of electricity, we're able to get data for the whole world, virtually the entire world from the IEA, so that made our lives a little bit easier. And this, I was totally not prepared for this when we did this. So everything I knew, of course, about the relationship between temperature and electricity consumption, I hadn't thought about it, but was basically from really wealthy countries. And I had this U-shape in my mind, and I said, well, the whole world's got this U-shape. On really cold days, people are going to consume a lot of power, and on hot days, they're going to consume a lot of power. And when we did this, here I'm going to divide the world into deciles of income. The data were surprising. So here, this 9th, 8th, 7th decile, and you can see that that U-shape is flattening. It's almost gone. And by the 6th decile, it's completely gone. And so what that's telling you is that and so that's, 60% of the world's population, there's no U. What that's telling you is that when hot days and cold days come, people in these places are basically unable to respond with the heating and cooling that, characterizes our lives here, characterizes this room, and are going to be much more exposed. And I didn't emphasize that here, but in the case of mortality, lots of the costs in poor countries are going to emerge in higher rates of mortality, whereas in rich countries, per that picture we had earlier, they're going to occur through lots of adaptation expenditures. And this is kind of giving you, filling out that picture a little bit. Okay, and also underscores the differences in what we're going to see around the world according to this analysis. And again, you can see these differences in the blue and the red. The last sector that I'm just going to dive a little bit into is on labor supply. And so what we observe is labor supply. We use a model to interpret that as the disutility from working in very hot days and turn that into dollars using that model. And here's how it's geographically distributed around the world. Let me just give you a flavor of what we found. This is the data that we were able to pull together for labor supply or time use surveys. We divided workers into two categories. High-risk workers who we said were in agricultural, mining, construction, and manufacturing. It's little arbitrary, but trying to capture people who are more exposed to the elements, and low-risk workers, all other sectors. And so among low-risk workers, what this data is trying to tell you is that there's no relationship between temperature and labor supply to a first approximation, maybe a little downward turn at very high temperatures, but it's pretty noisy. In contrast, for high-risk workers, there's this very sharp inverse U, and it kind of accords with one's intuition, but as I said, data can often be very disappointing, at least relative to my intuition for things. So you can see that there will be very large impacts on workers in those sectors. And when you put it all together, this is what you get when you combine the low risk and the high risk workers. And if you wanted to see what those damages are projected to be like around the world, again, you can see that the swatches of the world that have several billion people are expected to have, pretty substantial losses of labor supply, but we want to turn that into utils and then eventually to dollars. So the labor utility of working, and you can see how that's distributed around the globe here in a very, very unequal way. Okay, one other thing that I want to focus your attention on is, and you know it in conversation with your friends, that it's going to be very uncertain, any of these projections. And then sometimes, I think people intentionally say, well, if it's uncertain, we shouldn't do anything. But in economics, we know not to do that. And actually that uncertainty in and of itself has some value. And I want to emphasize that through our estimates, there are at least two sources of uncertainty, or there are two sources of uncertainty that we were able to characterize. There are some other sources which I'll come to touch upon at the very end. But the first is, we don't actually know if you double emissions, what's going to happen, double CO2 concentrations, we don't actually know what's going to happen to global temperatures. And so this is just giving you some sense of the range under different RCPs of global mean temperatures at the end of the century. And then as I kind of brushed against, there's lots of uncertainty about the economic impacts of climate change, be they in the mortality sector, electricity, or labor supply, and that's the gray area there is giving you a sense of that. Okay, and then when you pull it all together, like in Accra, you could see here, we don't actually know, we only have a distribution of estimates, and so there's an 8% probability that deaths will be greater than 500 per 100,000 annually, and about a 75% probability that deaths are going to be greater than malaria deaths today. And you can do calculations like that once you characterize the uncertainty. Do a similar thing for Sao Paulo. And so I want you to get a sense of how wide, how broad the uncertainty is, characterizing just a climate and economic uncertainty. And so here is when I put in the 25th to 70th percentile range. Here's when we put in the 10th to 90th percentile range. This is for RCP 8.5. You can see if we did RCP 4.5, which has smaller range, you would get the box plot there. But the main graph is for RCP 8.5. And of course, that uncertainty is in all the sectors. And of course, stealing from some intermediate micro textbook, one knows that the uncertainty in and of itself, getting rid of that would have some value, and that should be part of how we think about what the total costs of climate change are going to be. Okay, so I think we have maybe 5 minutes. Okay, great. So I'm going to, fun with numbers. I think that's what we're going to do here. I'm going to try and pull this together a little bit across all the different sectors, and this is labeled carefully, partial parentheses, or maybe the aggregate climate damages. Not quite sure which one where the parentheses should go around, but the key thing is just on the 5 sectors that we've been able to take on so far. And so if you have in mind conflict or some other labor productivity or some other sector, you're just going to have to add that to what we have. Ours is just for the 5 so far. Okay. And so if you did the year by year damages from climate change under RCP 8.5, you would get something like this. So that by the end of the century, we were experiencing, maybe that's 12 or 15 trillion dollars of damages per year. And this, you can also see that there's very wide uncertainty around that as well. If you wanted to express it as percentage of per capita GDP around the world, you have the same flavor here, which is that the parts of the world where several billion people live are poised to really kind of be in the bullseye of climate change with respect to damages. And then there's these great land masses to the north where there will be substantial benefits, as you can farm in Canada and places that you couldn't, and similar kind of stories for Siberia. Okay, and so I then, if you wanted to, here's, this is fun with numbers here, or maybe not fun, but informative with numbers. This is damages in 2099 as a percentage of that region's 2099 GDP. You can do it separate by rural, urban. I think for now, let's just focus on the total. And so the damages in 2099 in OECD countries would be about 1.5% of GDP. The low income, today's low income countries, it's about 12% of GDP. You can see it's about 8 times larger. And in that middle, the rest of the world that we talked about before, it would roughly be about 8% of GDP. And it helps underscore the way the very unequal or inequality of climate impacts. And, the average around the world, person weighted, is about 6.5%. Here's breaking it out by rural, urban, and doing it for different countries. And you can really see that there are some places where the damages are, they're not marginal. And are going to be quite extraordinary. And this is just a sampling of countries. And you can see there's places like Germany that on net are projected to benefit. Okay, now, my favorite hobby or professional hobby is the social cost of carbon. I was involved in setting it for the US government in 2009 and 2010 and left there thinking, boy, we really have to improve our game here. We can't rely on assumptions anymore. And so again, the social cost of carbon is the monetary value, the damages imposed by the release of an additional ton of carbon dioxide. And I'm now going to do an exercise for that damages associated with releasing a ton today. And for those of you who like to wonk out, like if you want a visual representation of what the social cost of carbon is, I can do it in this 4-panel graph. The first panel is the shooting out of an additional, blip of CO2. Then, well, what does that blip of CO2 do to atmospheric concentrations of CO2 out to 2300? And you can see there's this initial increase and it starts to go down. And I was a little surprised by how quickly that was, but fortunately there's a climate scientist on our team, and that's like the oceans sucking up the CO2. And then the CO2 is decaying and the oceans are starting to release it. And you can see the key thing is that ton of CO2 is going to be in the atmosphere for a very long time. This is its impact on temperatures over time. And then here's its impact on damages on an annual basis over time. And so you can see the additional marginal ton of CO2 has these pretty substantial damages. In case you were wondering, the average person in the US is about 16 tons of CO2 per year. So this is just to summarize, what are some of the advantages of DSEM versus the original IAM approach? They're listed here. What are some of the things that are outside of it? We don't have a complete set of sectors. There's lots of people who believe there'll be all kinds of regional interactions. That's like a nice word for people wanting to take land from other countries because they need to put their people somewhere. and that's probably outside where we are. But when it all adds up, at this point, we're coming up with an estimate of about almost $200 per ton. It's almost 4 times larger than what had previously been estimated. And if you want to do this kind of exercise of these 3 groups of countries that I've been carrying around, what you would say is that the additional ton of CO2 that's released today, this isn't damages in 2099, but will do about $11 of benefits for OECD countries, about $185, and let's call it $200 worth of damages in the rest of the world plus low income. And together that produces this $189 number. And I think is a really sharp way to highlight, again, the inequality of what climate change is projected to do. Okay, so then the last kind of fun thing you can do with numbers is what I talked about at the beginning. You can take this past year's global CO2 emissions, multiply them by the social cost of carbon and say, well, in some kind of green GDP accounting sense, how much would you mark down global GDP for the damages that we are doing with just this year's emissions? And it would be about $7 trillion, which is roughly 7% of global GDP. So let me just summarize. I think I was invited to talk about, or at least regardless of why I was invited, I've now spoken about that there have been advances in economics and climate science that are, I think for the first time, really allowing for the quantification of the global and local level impacts of climate change. 3 things I think emerge from that. The first are the damages are larger than we had previously thought, and they're much more heterogeneous than we had understood. You know, thankfully we have computers now. The costs are especially concentrated in today's poor and hot places, and are likely to be larger in rural than urban areas. And I've probably gone on enough about the social cost of carbon, and so I look forward to having a discussion around these issues with this incredible panel and feel honored to be part of it. So thank you very much.
Thank you so much. Thank you so much, Michael. That was truly outstanding, and we've all been waiting for that. So thank you for the insight. We've heard and read so much about it. Now, very quickly, without further ado, I'm going to introduce our 4 panelists who are very well qualified to comment on this. We're going to begin with Maureen Cropper. Some of you will know her very well. She's Distinguished Professor of Economics around the corner, University of Maryland, member of the National Academy of Sciences, Senior Fellow at Resources for the Future, former President of the Association of Resource and Environmental Economics, and so on and so on. Again, incredibly well published. She knows this work very well. And the World Bank has benefited tremendously from her, not least through all the PhD students over the years that we've had coming, that she supervised. After Maureen, we'll move to Ed Glazier. Again, needs very little introduction. Fred and Eleanor Glimp, Professor of Economics at Harvard University, Director for IGC's Cities Research Program, Editor of Quarterly Journal of Economics, written extensively on cities, segregation, urban growth, and perhaps everyone in this room has read his book, Triumph of the City. After Ed, we'll move to Emmanuel Clottey to provide us with some of the policy insights. Emmanuel is Technical Assistant to the Regional Minister of Accra in Ghana. And then last but not least, we'll move to Omar Masood, who is CEO of the Urban Unit in Pakistan, is a member of the Pakistan Administrative Service, was Additional Secretary of Finance in Pakistan, and has degrees from both Princeton and MIT. 5 minutes each, if you please, and then we'll put the floor open depending on how the time goes. Please.
Okay, thank you. Well, I'd like to start by saying that the Climate Impact Lab's work on climate damages really is path-breaking in terms of its empirical content. It's using data from countries around the world. It's been implemented at a fine spatial scale, so countries can actually go and look at these results at that scale. And importantly, it incorporates adaptation and the costs of adaptation. So the title of Michael's presentation was that climate change was going to magnify inequalities, and that's definitely true. When you look at all of the maps that he presented, the big damages are occurring in sub-Saharan Africa, in the Middle East and North Africa, in East and South Asia. And basically, this follows from the climate science. It is the climate science that is, alas, causing this. Regardless of what RCP we wind up at, whether it's 4.5 or 8.5, temperature increases are going to be greatest in these areas of the world. So from a policy perspective, what can we do about it? Well, one is to mitigate CO2 emissions. So we wind up rather somewhere near RCP 4.5 rather than 8.5, which we've heard a lot about the consequences of today from Adam Storygard as well as from Michael. The other, of course, is to adapt to temperature changes. And I think that Michael's presentation illustrated that very nicely. One of the slides you saw with regard to mortality damages, again, this is under RCP 8.5. If you looked at damages after adaptation plus the cost of adaptation, you actually had a figure that was 63% lower than damages if adaptation didn't occur. I do, however, have a few questions for Michael. One of the things that we saw it both in a map looking at the percentage of GDP, climate damage is expressed as a percentage of GDP in 2100 for countries around the world. We also saw it in table form where for low-income countries, the damages in 2100 would equal 12% of GDP. In the rest of the world, 8%. In OECD, only 1.5%. So I think it would be good for Michael to give the audience a feel for which of the sectors that he presented. So we looked at mortality, we looked at labor impacts, we looked at energy. We didn't quite get through agriculture and sea level rise, but they are part of DSIM. But it would be good to get a feel for which are the biggest categories of damages, because I think that gives people more insight into this. And also because of what was talked about this morning, I think the issue of sea level rise and damages associated with sea level rise, if you could elaborate a little, Michael, I think that would be good for the audience. One thing that isn't in these estimates, unless I'm wrong, is really looking at the impact of extreme precipitation events. So there was a lot of discussion about the problems of flooding this morning, and those precipitation damages, to the best of my knowledge, aren't part of this, but there may be plans to incorporate this. So I will be quiet and pass the baton to Ed.
Ed, over to you.
Thank you. It's great to be part of this. I have 4 small comments and 2 large ones, one of which is going to echo Maureen's last comment. First of all, obviously, this is important work. It's terrific work. It's deeply illuminating work. My 4 small comments. One, obviously, I was drawn to the urban versus rural effects. It wasn't clear to me if those were sort of accounting differences between urban and rural, or there were interactions with living in a city and mortality that we actually believed in, and how urbanity then interacts with other aspects of the country, like its income. Second small point. The rich versus poor electricity. I sort of knew that because of a paper that I wrote 10 years ago with Siqi Zheng, who's sitting there, and Matt Kahn, where we actually looked at, it's a paper called The Greenness of China, that followed up our work, Matt Kahn and my work, on carbon emissions in different parts of the US and electricity use. And one of the things that was really striking was that China actually did heat itself a lot. It didn't heat itself with electricity, but it sure as heck burned a lot of coal, sometimes directly, sometimes going through some kind of a heating system. And that was both meant that you weren't going to find find the electricity, but it also meant you were getting a bunch of stuff from the coal, which at least was bad for the environment. Third point on labor supply. This is, at my stage of life, you end up relentlessly plugging your students, but I have a student on the job market named Kristen McCormick, who is actually doing the labor supply of students and temperature in a large American school district, where there really are dramatic labor supply differences for the kids. Right? They not only don't show up on cold days, they don't show up on hot days either, and they also get into more trouble on hot days as well. So it extends up and down the life cycle, and perhaps missing school days is as important. Last point, and this is a very, Chicago price theory point on variance. How sure are we that, so variances can come in two forms. They can be a mean preserving spread to wealth, which is just as Michael suggested it. In that case, you just want to shrink your incomes, or it can be volatility in various prices, right? And, for those of you who remember your basic price theory, the expenditure function is concave, not convex in prices. And in fact, we actually like certain types of volatility because we can adjust to it, because we can actually move to, and I just wondered whether or not Michael had thought a lot about which types of these shocks are ones that are best thought of as mean preserving spreads to wealth, and which ones are saying essentially you're getting some price volatility that we can react to, and that's actually good. Two large points. Michael presented this mainly as new estimates of the social cost of carbon, and that's a really important thing to get. But most of our discussion this morning was about adaptation, and one of the things that I'm really interested in is the extent to which this model can be used for thinking about different extra forms of adaptation, different thought experiments. Obviously, since you're locating bodies in space, right, we can think about what we would get from moving them to different places, but we can also ask to what extent do rising income levels in different countries mitigate this, right? So how different is our world if India has become a lot richer in 2075 relative to what it hasn't been? So, and obviously the more that we can do on this, the more that we can guide our adaptation side. The last point, this is Maureen's point, and I want to echo it, I think water's bigger than temperature, quite honestly. I think water's bigger than heat. I think it's, at least in my world of cities in the developing world, I am much more afraid of cyclones, water tables rising, and everything that's associated with that. And so I really just want to echo her comment that the more that we bring in water into understanding what, unfortunately, I think the climate science on this is very difficult to understand. But, the more we can bring in anything about what we think the water damage and deaths are going to be from this, and again, what we can do to mitigate that feels like a really first-order push forward. But fantastic presentation, fantastic paper. Thank you.
Thanks so much. Yeah, well, Emmanuel, why don't we?
Yeah, thanks very much. So I like to really domesticate the tremendous presentation made by Professor Michael. I kept looking at the African map anytime it showed up, and I realized that it was receiving the biggest shocks from the challenges of climate change. And I was looking at it in a local context of Africa, where we've also started implementing the Africa Free Trade, and there's a free movement of people. And with the hindsight also of the migration in relation to climate change, it means those down south are going to feel the pinch as well. But interestingly, with all the factors that he mentioned, that's the mortality, electricity, loss of labor, they are happening already. So it's not waited till 2029. It's happening today. There are losses of jobs, mortality rates that high, and all those challenges. As I speak to you now in Accra, you have a highly urbanized population of about 91%. World Bank was estimating that in about 2035, you'd have over 50% of the urban population, living in the urban areas. But in Accra now, we've gone past that. So for some of these things that you're projecting into the future, we are experiencing them now. But there are also the local issues that affect us the most. Sanitation issues, transportation issues, flooding, and so on. So these issues are already happening. What I quickly would want to end with in a question form would be that considering the data you exposed showed that the challenge was more in the rural areas than the urban areas. So in considering an adaptation mode, would you advise that the focus be much based on the urban areas? Because people are already migrating from the rural areas to the urban areas. So should we focus on that for adaptation?
Thanks very much, Emmanuel. Umar?
Yes, thank you very much for having me. Well, it's just a pun upon the word. I can see technology, data, and research, a flood of technology, data, and research coming our way. I belong to the urban unit, and urban unit is at the juncture of what you call a think tank for government and the provincial and the local governments in Pakistan. So our challenge always has been how to, mainstream climate change, mainstream adaptation, mainstream, mitigation strategies. But before I read this paper, this challenge has been what I call at a 30,000 feet level, because resources are scarce. One thing that you need to remember, our country's resources are scarce. So whatever we have to do, we have to target it subnationally, because that's where the action is, and that's where you can target more effectively. And what this paper sort of leads to is that this is now possible with technology and data. And what I would also subscribe to this point of view, this is not only possible here in the USA, this is also possible in Pakistan. So, these things are within the realm of possibilities. Having said this, once again, when we are talking and you introduced me as the additional Secretary of Finance, so let me be a bit heartless when it comes to finance. There is going to be a trade-off. Now, by the numbers that I've seen, if it is rural which is being affected, what happens to the urban? So, where would our resources go? Even if we know subnationally that, these are the problems, where would our, resources go? That is very important. I completely also agree with an issue about water. Just let me give you a number. We estimate that irrigation water, because of temperature rise in cities in Pakistan, that according to our modeling, it is going to be about 2 degrees. That will result in an additional consumption of 10% more water, and that is going to come out of irrigation. Now, what is going to happen? So, these type of tensions are going to develop between the rural and urban areas. And while we know the numbers, these are just numbers. I'm just talking about the dynamics of these numbers, and when the resources are allocated, how these things are going to play out. But, despite all these things, what is more important, and what I feel this paper points out, is that when you are developing projects for mitigation, for adaptation, the one question that we were always asked, do you have a study backing it at our level or at a subnational level? We never had such a thing before. And I think this is now going to become a cornerstone. Even the social cost of carbon, we can talk about whether it is less or more. But whenever we are thinking of development projects, we are also talking about social costs, and development projects are evaluated like yardsticks. If you've been part of government, you would understand, that there is a process through which you go. And unfortunately, climate change expenditures have sort of failed that process, have sort of not come across because there was either lack of data or lack of enough subnational data or lack of local data. And I think, these things are going to matter a lot in the future. But once again, I would say rural-urban, divide and how this thing is going to play out is going to be very, very critical going out in the future. Thank you very much.
Thank you so much, Omar and the panelists. I'm now going to hand the floor back to Michael. And Michael, especially, any thoughts that you have on this issue of water that comes up, and some work that was done by other colleagues at the World Bank seems to suggest that, indeed, a 1 standard deviation increase in variability in water seems to be greater than that of temperature, with droughts hurting more than floods. But if anything coming out of your work for that and any of the other points you'd like to deal with, please, and then we'll open the floor up to the audience.
Yeah, so these are terrific set of comments from multiple perspectives, and I greatly appreciate them. It's a terrific group you put together. So obviously, common theme is water. I would say our work on water is probably the least mature of the work we have. And at this point, we kind of have inundation from permanent sea level rise, but have not taken full account of the flooding that will come from storms and things like that. And so that's outside of what our estimates have at this point. It's something we're actively working on, but it's complicated to do for the US alone, and which we're starting with to get our training wheels on, and more complicated to do around the world, and should include hurricanes and things like that. So that's, I guess, coming. And Maureen also asked, do we have estimates sector by sector at the local level or the 25,000 region level? And we definitely have that. And it's at least 3 of the sectors are available. Very detailed maps are available on our own website and on the UNDP's website that we did with them. I think another theme across the comments, very good comments, were to what degree, and maybe I'm misstating, but to what degree do these estimates reflect people getting richer? And I want to be very clear about that. So we're using SSP 3, and then at the end, the RFF estimates of how incomes are going to evolve over time. And all of these estimates account for the fact that places are projected to get richer, and then will be better able to respond, better able to respond to climate challenges. Let me see if there's other things that I wanted to hit upon. To Ed's point about the variance, we should probably try and unpack that more. That's a very good point. Then the nature. I don't really think we have price volatility. You should think of it as price volatility right now, but I want to think harder about that. And then to the 2 policymakers, these are, at some level, I'm a little bit of a loss on what to say here. The projections are, particularly for both of your countries, I don't know what the right word would be, but unfavorable would be a vast understatement. And is there a secret sauce here in terms of adaptation? I think the secret sauce is a little bit in where Maureen was pushing me to go, is trying to understand sector by sector, location by location, what those damages are going to look like, and then building adaptation strategies in response to them. I should say, and I think this is actually I want to interact that with both of your interests in urban versus rural, and then Ed's comment. He asked, had we in econometrics talks fully interacted urban with all of the estimates, or had we just tagged places as urban and seen what happens? And so we did the latter, partially because I think my low standing among urban economists, I don't really know how to define urban as it evolves over time. And so we probably did the low rent version of what Ed was thinking. But I think to the 2 policymakers, I would say I would not focus so much on urban and rural, and focus much more on location by location, in what sectors of the damage is really going to be concentrated. And then I think adaptation strategies would follow from that almost naturally.
Can I just add one response to that? I think one of the things that many people in this room would be interested in knowing is to what extent either restricting or encouraging the growth of cities is likely to be helpful or harmful in this area. And that's the sort of thing that would come out of thinking about getting these interactions right.
Absolutely. I think, today, what I like instinctually, it's got to be that getting more people in cities seems like it's got to be a plus. But from the data, being limited by the data, we don't have what you're asking for. So I want to be a little timid in fully agreeing there.
Thank you so much to our panelists and to Michael. The floor is now open. If anyone would like to walk up to the mic and ask a question, you can be brave. No one over here bites. Is there anyone? Oh, yes, we have. Great, please.
Hi, I'm Jana Lee. I'm an economist at the U.S. Department of Housing and Urban Development, and we've been using social cost of carbon in some of our rulemaking. So glad to, see this panel. But I was just wondering if Professor Greenstone, if you could comment a little bit more maybe on the other greenhouse gases. I know there's the social cost of methane and nitrous oxide, and I don't know if you have also done research on those, and if there is a good way to talk about them. Is it better to sort of talk about the social cost of greenhouse gases in aggregate or separately?
Oh, terrific question. So there's multiple greenhouse gases. CO2 is a predominant one. Many rules, for instance, rules about methane releases from oil and gas operations in the U.S. Certainly, you need to have a social cost of methane for that. Everything we've done, we've also done for the different greenhouse gases. And as you well know, methane magnifies temperature much more much more virulently than CO2, but it disappears from the atmosphere much more quickly. So it's going to put the social cost of methane is going to put a much greater weight on damages that occur in the near term, or damages do occur in the near term from that than from CO2. So anyway, it's the method is straightforward to apply to any greenhouse. You make up your own greenhouse gas. We can run it through our model.
Thanks very much. Any other? Please.
Hi, I'm Monica Banslin with USAID and here in Washington. So I have a question about sort of making some of this information practical for policymakers. So even from my perspective, we really run into issues of how do we prioritize one geography over another when we're thinking about adaptation support. And I find this research so interesting to finally bring this down to a very location-specific level, which is, I think, what we need so that we're making better decisions about that take inequity into account. But I'm curious about, from a practical standpoint, how do we make this practical for policymakers, the cities that we work with, countries that we work with, and even for large organizations like the one I work for?
Yeah, so one of our motivations was for setting out on this was I just found like the typical statement about climate damages to be, global GDP will be down by 3% at the end of the century, like totally meaningless. Nobody lives at the mean. Nobody really knows what any of those things, they know each of the words in that sentence, but they don't know them in that order. They don't understand them in that order. And so one of the goals was to really try and develop localized estimates. And it's something we're working hard on, and probably there's a lot of room for improvement on trying to communicate those results. So we did start this partnership with the UNDP, where they took our local estimates sector by sector, and you can download them and look and see in our 25,000 regions in the US account to accord to a county, so you can see them at the county level. In China, they count, in India, they count to district levels. They're matched to districts. So you can see, like at those jurisdictions, what the damages are going to be. And as I was mentioning earlier, like, they can be concentrated in agricultural yields or what are the, or whatever it is. And I feel like we have a pretty big team. We're 30 people. I think to really effectively communicate that in countries around the world, you need more firepower than we have, and probably fewer researchers and more people are expert at communications. So like we're building the foundation for it and trying to put logs on the fire for it to be used, but I think it's going to require some real professionals coming and taking that information.
Yeah, may I say, something about making it practical? Well, I come from the policy world where these things are being implemented. While they may not have so much knowledge about global climate change, intrinsic knowledge about climate effects and weather effects, they are very good at it. So the body which is going to, say, approve mitigation expenditure or an adaptation expenditure, they know the districts, they know the divisions, they know the province, or what particular, climate change patterns are there. Some of them have served in those areas. And for them to know this local level effect is extremely important to go ahead and sanction that project. You know, you can come up with a very, very good project, and it's not going to break the bank, by the way. I'm speaking from the country of Pakistan. I'm telling you, climate adaptation and mitigation is not going to bankrupt us. Something else might bankrupt us, but not that. And because of that, you just need to, you know, make sure that you have that local level knowledge with data. If you are able to put together this thing, you would see this process unfolding, and once it starts unfolding, it's like a template, and it will follow. You know, the dynamo at the moment for climate change is not running in these countries. You really have to, you know, have a spark to actually start it. That's all. Thank you.
So one way to think about what my point about using this as a diagnostic tool is exactly what you had in mind. So you can imagine from a USAID point that you had, I don't know, $1 trillion to give away to countries. In principle, and we know that the US government is just ready to do that. But you can imagine exactly using his model saying what happens if GDP goes up in this country, where do you get the most bang for your buck in terms of that? And you can imagine that in other projects as well. But the main thing you should be using it for is look at all the people who are going to die because of what we've done as America. Shouldn't USAID's budget be larger? And that seems like its biggest use.
Okay, we're going to have one, well, there's two last questions on the floor, so we'll take both of those, and Michael will be quick in responding.
Hi, Rafi Balian. I'm with the U.S. State Department, Office of Environmental Quality. I just wanted to get a sense from you in terms of when you were looking at GHG emissions, was it specific to carbon, methane? I want to understand the role of pollution as a climate forcing impact, and looking and understanding at rising levels of pollution as it kind of interacts with climate change, and also mortality rates. And if that's been modeled, if that's been included in your model, or it has not, because the cause of mortality from pollution is rising, pollution levels are rising. And so I wanted to understand the interaction of that climate forcing impact as well. Thanks.
Let's take the second question as well, Michael, in the interest of time, and you can answer both, please.
Hi, thank you. My name is Sophia Nong. I'm with USAID Washington, and my question has to do with the model. I'm wondering if it factors in things that are already being done by governments, smart cities, whatever is considered to be addressing climate change. At the same time, we're seeing damages playing out. But I also, I come from Zimbabwe, and so this question is for the gentleman from Ghana and even from Pakistan. What do policymakers see as the rationale for maybe partnering with World Bank or USA to engage in smart cities, while at the same time the existing urban areas are still struggling with things like sanitation and just adaptation in general? Thank you.
Okay, I did say last, but this will be the last.
Thank you so much. Anna Gren from the Climate Change Group. I was listening to the beginning of the presentation, and regarding the analysis you're doing on the temperatures impacts on society as a whole, and as climate change affects men and women differently, are you also maybe looking at some of those dimensions? Thank you.
Okay, so let me try and touch on those quickly. If I understood the comment from the person from the State Department, this is just about greenhouse gases, and I think your question is, hey, what about conventional air pollutants like particulates and things like that? So I have a whole separate stream of research on that, and I desperately wanted to integrate the two. It requires like an energy systems model for the world, and where you know how much coal is going to be used around the world and how much natural gas, and it's like on the to-do list. So we haven't integrated the two, but just to, you know, I do believe the greatest current threat to public health around the world is particulates air pollution. It's not greenhouse gases. It's killing more people today than anything else, and so I'm completely sympathetic to that, and it's just not integrated in this analysis. Yes, I think the second question had at its core the degree to which we've allowed for, or I'm going to answer the question I thought was being asked, but it might not have actually been a question. One thing that's outside of the model that's really important And it is actually, in a somewhat dark presentation, a little bit on the plus side is, our rate of adaptation that we're projecting forward is from a period where I think people didn't really think that climate change was that big of a deal. And so if we were to now unlock climate biased adaptation, so that is that we were getting more innovation, climate biased innovation on things that are responsive to climate, then I think our estimates are likely to be a little bit smaller for that. And so my favorite example of that is, and you can go Google it, it's the most amazing thing. There are actually now t-shirts that are air conditioned. They look horrible, like no one would ever want to wear it. It looks deeply uncomfortable. But, in 50 years, will Nike have figured out how to do that in a way that is like feasible to wear? Probably. And so I'm not saying that means we don't have to worry about climate change. I'm just saying there's all kinds of climate biased innovation that has probably only begun to scratch the surface of. The last thing was about gender, and we just haven't had the data to take that on in a serious way. So,
very quickly, Omar and Emmanuel. So, why don't we start with Omar and then go to you, Emmanuel? Okay.
Yes, if I recall, your question was going for smart cities instead of going for more issues like water and sanitation, and why do we do this? In fact, I would not say that these are exclusive to each other. Smart cities is a concept, but if you have data for something, if you have robust evidence for something, you'll always go for the one for which you have more robust evidence. And I think what has happened with the smart cities is it's nature abhors a vacuum. So there was a vacuum and smart cities sort of plopped. And there was, smart cities and IBM and so many other companies actually, pushing that agenda. But what I would really advocate is that is a different stream going at a different speed. The priority is different. This is a different priority altogether. And this in no way would mean that we would be taking away resources from critical or essential sectors to pull towards smart cities. In fact, from my experience with the bank in Pakistan, is the bank has never sort of pushed for smart cities ever in the last 2.5 years that I've been at the urban unit. They've come for more sort of critical issues with respect to climate change and so many other, urban challenges. Smart cities are iterative process, best left to, I think, the city's own sort of inclination on how to go about it. I think those are much more better developed models rather than taking a cookie cutter approach and adopting a template from abroad. That would be utter disaster. This is my experience. I would now ask Emmanuel if he has something to say on that.
Okay, just to add a little more points to yours. The two can exist at the same time. We can keep our eyes on the basic issues of sanitation, but that's not to say smart cities would have to wait for tomorrow, because indeed, it also comes to solve some endemic challenges, which without would probably take us a long time to be able to solve. For instance, urban policing can be addressed with smart city solutions. Revenue mobilization, early warning system for disasters and so on, social services provision, digitalization on different platforms. As we speak now in Ghana, kind courtesy, the vice president, you can now be able to renew your health insurance just on your phone. But in the past, it will probably take you about a month to be able to do so. In Ghana now, there's one of the largest drone medical services provision in the whole of Africa. That's Smart City Solutions. It solves a critical problem where a drone can be able to send some medical supply beyond some inaccessible routes that hitherto people were just dying for no reason. So they come side by side. So we pay attention to these critical basic issues, but the smart cities are also quite critical. And we have to look at all of them based on their importance per time for effective social services delivery to our people.
Thank you. Thank you so much, Emmanuel. That's all we have time for, unfortunately. We could spend a lot more time, but let's finally give our speaker and our panelists a hand and thank them. And thank you all.
Thank you.